So today we're going to go ahead and go over a difference op amp for challenge assessment 6. Here is the built circuit diagram, the one that I picked. Drew this out. So a difference op amp is just a type of amplifier that amplifies the difference between two input voltages, and it suppresses any voltage common to the two inputs. So the circuit's a combination of an inverting and non-inverting amplifier. And to calculate the output voltage of this differential amplifier, I'm going to use both the inverting and non-inverting outputs and add them together. So here's just my theoretical analysis to calculate the final output voltage. Just a bunch of, it looks like a mess, but it's actually pretty easy. I can just go over a couple parts of it right here. Basically, to get my final output voltage, I need my Vout plus my Vout minus to get the final value. So, this is just me calculating those values in here with the given circuit. And I did use some gain in here, non-inverting gain and inverting gain, as you can see by the G minus and G pluses. And this all got me to this big equation right here to get me my V out, my final output voltage value. And I went ahead and just equated my R3 to R1 and my R4 to R2. But really, in the circuit that I built in this slide, I just made all my resistors equal to 10,000 kilo ohms. But from this equation here, we can simplify this to my output voltage being R2 over R1 equals V1 minus V2, which equals R4 over R3 times V1 minus V2. So in this slide, here is the circuit that I drew out a couple of slides ago, and I went ahead and simulated it in Multiism and calculated the output voltage. The output voltage here is 2 volts. And that is with my V2 equaling 2 volts, my V1 equaling 4 volts, and then all my resistors set equal to 10,000 kilo ohms. Then I went ahead and calculated this just to make sure, and my Vout, or my output voltage value, ended up being 2 volts. That matches my simulation. So that's a good first step. And then I went ahead and built the circuit. You can see the op amp and some resistors, a bunch of wiring. And I went ahead and hooked it up to Multiism, and I was having some problems with the circuit reading correctly, but then I hooked up a multimeter to get just my readings, and they all came out to the values that I was expecting, and it performed the theoretical signal manipulation that was calculated in the last slide. So, it worked. Thank you.